So hash table is this. Hash table is a large size of tables consisting of keys and values. So we have keys and values. Hash function is actually used to find an array index for a key. So we have this ID and F801117123456 is going to be 70. So there is a certain function, and that's being called the hash function, that turns our ID into the index. Here, the array index is an index in the table. A key is a unique identifier of a value. A parameter to find this array index through the hash function, and a value is myself. So characteristic is this: one key can be associated with one index. That we can do. However, let's imagine that our function is somehow mapping multiple keys into one index. Then why it can happen? Why can it happen? Actually, we need to talk more a little bit of mathematical sense here to understand this. Before we go further, let's define a further elements. An array element is a slot and a bucket in our hash table. Okay. So hash function is a function, and there is a mathematical definition of a function. So hash function is used to convert values key to the array's index. So registration number ID into the index of that array. For example, if we give this number, then it returns a certain index that where the ID's value being stored. Here, that's the the ID number, and that's the index, and F is a particular hash function. And perfect hash function, let's imagine. Either if we have an unlimited space, or if we have a limited input size, right? Both are unrealistic, right? Even though the memory space can be bigger, but it's not going to be unlimited. In that case, we have to limit our input size. So, but at the same time, we also always consider that infinite size of problem at the same time. So these are all kind of cannot be achieved. But in practical sense, the input size often limited. So this somehow works, okay, in the real world. But mathematically, this is the perfect hash function. Then in that case, we might have a chance to create a bijective hash function. What's the bijective function? Actually, that's this. It's called one-to-one mapping. Only one x is being mapped to only one y, right? It's the bijective function. And every x can be mapped to y, and every y are mapped. That's the bijective function. However, in that case, still you have to know the characteristic of the keys, the distribution of the keys, so that we can carefully design this perfect hash function. But this is not going to happen, because these are all three conditions are kind of very difficult to achieve. So we just limit ourselves to have a good hash function. So for example, hash function wants to be a uniform distribution. Why is that? Actually, we can look into much later. So if we have a high frequency of value here, and let's imagine that this segment always going to be mapped to index of 70. In that case, index of 70 is going to be very crowded, and it's not going to be the bijective function. It's going to be actually the surjective function. Some of the x can be mapped to the same y, and that's a collision. we want to limit this, but so to limit this, we want to have more like this uniform coverage of this, so that we can reduce the collision. But why is difficult? Because that actually creating a uniform distribution is difficult. Why? There is a uniform function everywhere. But if you keep drawing numbers from uniform distribution, because of the central limit theorem, which you have to learn from the stat course, because of that theorem, you end up making this normal distribution, so that there is a peak. So that's a bummer, right? So, okay. Creating a uniform distribution from a certain distribution is very difficult, and creating a pseudo-random is very difficult, right? And there is a somewhat relation to the password encryption algorithm. For example, if you have a certain ID, and then you can convert that ID into a password that can be transmitted to the wire, and this wire can be always listened. In that case, we want to make this converted value cannot be re-identified to any bad person who is eavesdropping, right? Eavesdropping in Korean means 도청, right? So, in this case, at the same time, we want to have the pseudo-random and want to have a uniform distribution. We don't want to have any distinct, this peak we don't want to have. But because of this central limit theorem and this property, we always have a peak. And this peak is going to induce this surjective function. And this surjective function, actually there is a collision between, so I have this registration number and index is this. I have this different identification number and I got the same index. And who is going to store at that index? That's a collision problem, and that's the problem that we have to solve. Perfect hash function is bijective function, but often our good hash function is limited to the surjective function, so it's not going to be good. So we need to somehow figure out how to resolve this. Okay. And additionally, our hash function has to be the low cost and deterministic and variable range. If we always have to calculate so we have to do many mathematical operations to calculate the hash functions, that's going to be very bad. All right. Finally, this injective function, is it a realistic assumption? Actually, it's not, right? Every x should be mapped, and when every x is being mapped, y has an empty space. We are assuming that x is going to be very big, and y should be limited, right? And this is talking, this is talking the other way around, right? It has a bigger size and it has a limited size, so that it can have an empty, unmapped space. We don't want to have like this, right? And it's not going to happen in the real world cases.